Could the universe still be inflating? A journey into the cosmic mystery. What if the universe as we know it is just one small bubble, adrift in a vast, unseen sea of endless creation? Imagine a reality where the cosmic clock has never stopped ticking, where the grand forces that shaped our observable universe are still at work, elsewhere, beyond our reach. Could it be that the universe is still inflating, at least in some far-flung corners of existence? To answer this tantalizing question, we must delve into the strange and fascinating world of modern cosmology. The echo of the Big Bang. It all began with the Big Bang, or so the story goes. But the bang wasn't a simple explosion. According to inflation theory, the universe underwent a staggering transformation in its infancy, a split-second burst of exponential expansion that stretched space itself faster than the speed of light. This phase, known as cosmic inflation, smoothed out the wrinkles of space-time, laying the groundwork for the orderly cosmos we inhabit today. But inflation didn't simply turn off all at once. In fact, some models suggest it never entirely stopped. Eternal inflation, the universe that won't quit. Here's where the plot thickens, the concept of eternal inflation. Picture the early universe as a bubbling pot of soup. Tiny quantum fluctuations, random jitters in space-time, determine whether a given region settles down into a calm, post-inflationary state or continues boiling in a runaway expansion. According to this theory, while our observable universe transitioned out of the inflationary phase roughly 13.8 billion years ago, other regions of space-time might still be in this explosive mode of growth. These ever-inflating regions give rise to an astonishing possibility: the creation of countless new universes, each forming their own unique bubble in a vast, incomprehensible multiverse. If true, our universe is just one tiny part of a much larger, and much stranger, reality. What about the universe we see? The observable universe, the cosmic expanse that telescopes can explore, shows no signs of ongoing inflation. Instead, we see galaxies forming, stars burning, and the delicate cosmic microwave background, CMB, radiation, the faint afterglow of the Big Bang. These features tell us that inflation ended locally long ago, allowing the processes that shape galaxies, stars, and life to begin. And yet, our observable universe may be just a drop in the cosmic bucket. Beyond the edges of what we can see lies the unobservable universe, a region that may stretch infinitely far. Could this hidden domain still harbor inflation? The multiverse, infinite realms of possibility. If eternal inflation is real, it leads us to a radical conclusion: the multiverse. In this framework, inflationary regions continue to spawn new universes, each with its own distinct physical laws and constants. Some might be lifeless voids, others could teem with unimaginable forms of life. This cosmic lottery is driven by quantum fluctuations, the unpredictable behavior of particles at the smallest scales. These fluctuations create variations in energy density, causing some regions to exit inflation while others remain trapped in an eternal cycle of rapid expansion. Here's the kicker: these other universes are, by definition, beyond our observational reach. They exist outside the bubble of our observable cosmos, separated by ever-expanding distances we can never cross. But what about dark energy? Here's a twist to keep you on your toes. While inflation ended in our observable universe, something eerily similar is happening today. Our universe's expansion is accelerating, driven by a mysterious force we call dark energy. Could this phenomenon be related to residual effects of inflation? Dark energy and inflation both involve a form of energy with negative pressure, which causes space-time to expand. While most scientists consider them distinct, some speculative theories suggest that dark energy could represent a leftover, echo, of inflation, subtly influencing the universe's evolution billions of years later. Could we prove it? The idea of eternal inflation is both thrilling and maddeningly elusive. By definition, regions still undergoing inflation are beyond our observational horizon, expanding faster than light can travel. This means we can't directly see or measure them. However, scientists are exploring clever ways to test inflation indirectly. For example, minute patterns in the cosmic microwave background could provide clues about the inflationary process. Similarly, the detection of primordial gravitational waves, ripples in space-time produced during inflation, would be a game-changing confirmation of these ideas. But proving the existence of other inflating regions or the multiverse, that might forever remain a question for philosophers, or perhaps, a lucky civilization in some distant bubble universe. Why does it matter? Beyond its scientific intrigue, the idea that the universe is still inflating challenges our deepest assumptions about reality. It forces us to confront questions about the nature of existence. Are we just one fleeting spark in an infinite cosmic symphony? Could life and consciousness arise in other universes, governed by wildly different physical laws? Understanding inflation, and its possible persistence, isn't just about decoding the universe's past. It's about glimpsing its future and contemplating the ultimate fate of everything we know. Will inflation continue eternally, spawning new universes without end? Or is there a grand conclusion waiting somewhere in the cosmic future? The endless adventure. The universe is vast, mysterious, and full of surprises. Inflation might have ended for us, but the story of the cosmos is far from over. Somewhere out there, perhaps in a realm we can never reach, inflation may still be raging, a relentless engine of creation, forging new worlds and new possibilities. As we continue to probe the cosmos, one thing is certain: the more we learn, the stranger and more awe-inspiring our universe becomes. Could it still be inflating? The answer, like the universe itself, might be far larger and more extraordinary than we can imagine.